Alright guys, this is section 2.2. Our goal here in this section is to be able to find slopes of lines and rates of change. So slope is the ratio of vertical change, or the rise, to the horizontal change, or the run. So you guys have heard before that the slope is rise over run. And a formula for this is m, or slope, is equal to y2 minus y1 over x2 minus x1. So we're looking at ordered pairs or points that have x, y as an ordered pair, and we're plugging those values into this slope formula. So for example, here we have a skateboard ramp, and it has a rise of 15 inches and a run of 54 inches. What is the slope? So if we kind of sketch that out, here we have this ramp, and it looks like an awful ramp. So a little bit better one here. Okay, it has a rise. So the keyword there was rise, so it's going up, was 15 inches. And a run, so the horizontal way, is 54 inches. Well, we want to know the slope of this. Okay, some of you guys automatically want to say, oh, a squared plus b squared equals c squared, right, for this ramp. Well, we can't assume that this is a right triangle, because remember that only works with right triangles. So this is why we need to use the slope. Okay, so our rise over run formula, because we don't have any points going on, so we can't use the y2 minus y1 formula. So we're just going to use rise over run. So the rise was 15 and the run was 54. So that can be reduced all the way down to 15, excuse me. So 15 out of 54 reduces to 5 out of 18. And you could leave it like that in inches, or if you want that as a decimal, that's about 0.278 inches. So whichever one works. That is the slope of that skateboard ramp, which is pretty small for a slope. Okay, so then in example 2, here we have the slope, have to find the slope of a line passing through these points. Okay, so, well, I have 2 points going on, so I need that trusty formula. So y2 minus y1 over x2 minus x1. So what I'm going to do is label my ordered pairs. And I would recommend you guys do it too every single time, so it helps you set it up right. Because -2 is my y2, or -1 is my y2, it goes on top. And it's subtracting out my y1, which was 3. Then in the bottom, I need my x2, which was 2. Subtracting out my x1, which was -1. Okay, so up top, -1 minus 3 more is -4. Then in the bottom, I have a change going on. Okay, 2 negatives side by side make a positive. So that's like saying 2 plus 1, well, that's 3. And -4 out of 3, well, that can't reduce down. So here's my slope. So I have 4 different kinds of slope. Positive slope rises from left to right. So here as a little sketch, well, it's going up from left to right. Negative slope falls from left to right. Okay, so it's going down. Zero slope is horizontal. It's a horizontal line. And then undefined slope is a vertical line. Okay, so here there are 4 different kinds of slope. Sometimes it can be tricky to see, okay, is it going to be zero slope or undefined slope, given an equation. Okay, and we simplify it all the way down using the slope formula. But I have a little trick here. If it is a zero slope, you're going to get a fraction that looks like 0 up top and some other number in the bottom. I'll just call it k. Well, 0 out of anything is 0. That's why it's okay to have 0 up top. So that is 0. But if I have 0 in the bottom, okay, anything out of 0 is undefined. Okay, where n is any old number and 0 is in the bottom or in the denominator. Because if you were to try to do a number divided by 0 in the calculator, say like 7 divided by 0, well, that's going to give you a big old error in the calculator because that is actually undefined. That's why it's not okay, or NO, to have 0 in the denominator. So remember those tricks to help you figure out mathematically when you go through the steps in your slope formula to reduce down to find a slope. If you have 0 in the top, that's okay. If 0 is in the bottom, well, that's undefined. That's a bad thing. So in example 3, we're going to see, okay, without graphing, tell whether the line through the given points rises, falls, is horizontal, or is vertical. So remember, you have the slope formula. So y2 minus y1 over x2 minus x1. And we're going to use that with each of these points. So in part A, well, slope, label your points. Okay, so 1 is my y2, and so is my y1. x2 is 3, and I'm subtracting out negative 5. So 1 minus 1 up top, that is 0. And 3 change two negatives together makes 8, because 3 plus 5 is 8. So 0 out of 8, well, that's okay. That is 0. So we said, well, 0 slope, that is a horizontal line. Okay, so that is horizontal. So that's part A. Okay, this next one, doing the same exact thing. Setting it up, well, y2 is negative 4. Subtract out your y1, which is 0. x2 is 2. Subtract out x1, which is negative 6. Well, negative 4 minus 0, that is negative 4. And change in the bottom. 2 plus 6 is 8. But negative 4 out of 8, they can both be divided by 4. So negative 4 divided by 4, well, that's 1. Okay. And then 8 divided by 4 in the bottom. That was negative 1 on top, sorry. 8 divided by 4 in the bottom is 2. That's the same thing as negative 1/2. Okay. So, since it's negative, that is a falling slope. So this one falls. The next one here, still label x1, y1, x2, y2, slope. y2 is 8, subtract out y1, which is 3. x2 is now 5, subtract out x1, which is negative 1. Well, 8 minus 3, well, that's 5. Change in the bottom. 5 plus 1 is 6. So my slope here is 5, 6. That is positive. So this one rises, since it's a positive slope. And then here in the last one, x1, y1, x2, y2. Well, y2, excuse me, is negative 1. Subtract out y1, which is 6. x2 is 4. Subtract out x1, which is 4. Well, negative 1 minus 6 more is negative 7. And 4 minus 4 is 0. So 0 is in the bottom. That's a bad thing. Okay, this is undefined. Okay, has an undefined slope. And we said undefined slopes are vertical lines. Okay, not horizontal, because that is 0 slope. Okay, so now we have the difference between parallel and perpendicular lines. You guys should have used this in geometry. Okay, parallel lines, they're parallel if and only if they have the same slope. So keyword here, parallel, same slope. So m1 is equal to m2, m being slope. Okay, Perpendicular lines, they're perpendicular if and only if their slopes are negative reciprocals of each other. Okay, so for instance, or example, if I have my first slope is 4, okay, and I want the negative reciprocal of that, well, 4 is really just 4 over 1, right? So if I flip the fraction, okay, I have 1 over 4, and I got to make it negative. So the negative reciprocal. So if you see the perpendicular, you think flip, flip. Because you need to flip the sign and flip the fraction. So in this last example here, what we're going to do is find the slopes of these lines separately and then compare them to see if they're parallel, perpendicular, or neither. So first, I need to remember my slope formula, right? y2 minus y1 over x2 minus x1. Okay, so label your points, x1 and y1, x2 and y2. So if I want this first slope, well, y2 here is negative 1, subtract out y1, which is 2. x2 was 0, subtract out x1, which was negative 2. Well, up top, negative 1 minus 2 more is going to give us negative 3. And then change in the bottom, 0 plus 2 is 2. So here's our first slope. So that was line 1 slope. Now I need to figure out the slope of line 2. Okay, so in this one, y2 is 3, subtract out y1, which was negative 1. Well, x2 here is 2, subtract out negative 4, which is our x1. Up top, change, 3 plus 1 is 4. And then in the bottom, change, 4 plus 2 is 6. But these both can be divided by 2. 4 divided by 2 is 2. And 6 divided by 2 is 3. So here is our slope for line 2. So we're comparing these slopes. So we said parallel would be the same slope. Well, negative 3 halves is not the same as 2/3. So parallel is out. Perpendicular, we said, well, they got to be negative reciprocals of one another. So if I take negative 3 halves and I flip the sign on that, well, that's positive. And if I flip the fraction on that, that would be positive 2/3. And that is actually what line 2's slope is. So these ones are perpendicular to each other. So they are perpendicular lines.